If you look at the videos in my YouTube channel, you're gonna see that I have some about 3D printing and some about FPV drones. And there is a reason, because there is a synergy between these two worlds that is very interesting. And today I want you to see what I mean with this synergy, showing you how to design a part and how to use your 3D printing to do your drone much better. Many of our drones, if not all of them, use 3D printed parts, normally to support the receiver or the antennas or even to protect the arms. But the real power of this combination comes when you, as a user and owner of a 3D printer, can start designing your own parts. And you might think this is very difficult to do, but I'm here to tell you it's not. And you can always start simple to gain experience and get better at creating and solving problems for yourself with your 3D printer and make your FPV drone better and potentially unique. I have enough knowledge on this topic of 3D printing and FPV that I could be dangerous, but I'm not excellent at it at any point. That's the reason why I decided to call a friend of mine who is, I will consider her an expert, so she can drive us through how she thinks when she's going to design something in a CAD program for the drones for the FPV world. Her name is Riley, and she has the luxury to be able to model whatever she wants in the 3D program. And it's funny because when I talk to Riley and I say that I wanted to do this part or that part, she tells me in her experience whenever she wanted to do something, like she ends up modeling the whole thing, the whole drone, just to make sure that the part that she's doing is going to fit correctly. And if you look at her page in GrabCAD, you see that she has modeled hundreds of things there which are super cool, and you can see the quality of work that she can do with a CAD program. My objective here is not only to talk to her about how to design a part, but also how to optimize it for the kind of printers that we have, FDM 3D printers. Because the process with FDM 3D printers sometimes is misunderstood. Thinking like if you're very new to 3D printing, you think that whatever is designed in a 3D CAD program, you're gonna be able to print it. And it's not always correct. You have to keep in mind that 3D printers lay layer by layer in single lines to build their parts. And this means that you always need to have something underneath to be able to put the next layer. This brings as a consequence that you cannot print in mid-air. So when you are designing a part, you either have to go up slowly in an angle so you can have always something underneath, like on the layer before, or you have to design parts that never have something hanging in the air. Here are Riley's tips.
Tip number 1, prepare the model. In order to have accurate parts, you need references. In the FPV world, a picture of, for example, the frame will help you a lot. In this case, a picture can be found at GEPRC's website and then imported into Fusion as a canvas. At this point, it's just an image, which can be calibrated knowing that the stack size in this frame is 25.5 by 25.5 millimeters. Tip number 2, define your contact areas and take measurements. At minimum, we will need standoff diameter and height. Having the top plate thickness and general profile can add more design flexibility to the design. Tip number 3, pick a print orientation. The model will be printed using an FDM 3D printer, so we have to think about how this model is going to be oriented for the best printability. Usually, the flattest surface will be the best to contact the build plate. Tip number 4, avoid 90-degree overhangs. Overhangs are something we should try to avoid when 3D printing, but they are many times mandatory. If you are adding one, do 45 degrees or steeper. This may mean you need to use supports when printing. Tip number 5, add tolerances. Any part that will be contacting another part should be given a tolerance. Tolerance will vary depending on the printer's accuracy. Find what works for a tight fit and a loose fit. I use 0.1 millimeters for a tight fit and 0.25 millimeters for a loose fit with my machine, but this takes a bit of trial and error. Tip number 6, do not add science holes, aka lightning cutouts. Holes that serve no purpose other than weight reduction will not help you significantly reduce the weight of such small TPU parts, but you may see a decrease in durability and you will increase model complexity, making changes more difficult. Tip number 7, finish details. Fillets and chamfers added to sharp corners can increase strength and also make the design more aesthetically pleasing. It's recommended to send your design from time to time to the slicer to check for printing problems.
A few words about TPU. TPU is kind of a filament that is very flexible, and because of this, in the past it was something difficult to print. Printers, all printers, and still some printers out in the market were based on the Bowen tube, which meant that the filament has to be pushed from a long distance into the printing head. These days, many printers like the A1 and the P1S, they have what is called direct extruder, which means that they take the filament and they push it from a very, very close distance. That means that the effect of a flexible filament like TPU that we had before, it's not gonna happen anymore because you're pushing directly from a very close distance and it's not gonna be a big problem to print it. Printers like the A1 are basically made to print TPU. They are perfect to do it, and we're not gonna have those problems that in the past many were referring to, oh, now we have to print TPU, how do we do this, how do we do that? To test what Riley has created, I'm going to be using what I think is the most friendly printer for FPV enthusiasts in the market today. I'm talking about the Bambulabs A1. This printer, it's very easy to use, it's kind of ready out of the box, you have to put some screws in. It has the direct drive that I've been talking about for TPU, and it's very inexpensive. Users will find that this printer is not only easy to use, but Bambulab has done something very interesting with the whole ecosystem. They have the filament, they have the printer, they have this place called Makerworld, where they have a lot of different models that you can download and print directly. And they're making everything work together very nicely for the easiness of use of the end user. That's the main thing. They're making it very, very easy for anyone to get into this. So if you are into FPV and you are thinking more that you are flying and you're doing your drone stuff, but you want to get into 3D printer as well and starting in a very easy way, this printer that you have here, it's what I would say the best entry point that is available today in June 2024. As I mentioned, this printer is very good at TPU, as long as you are not using the AMS Lite that you can find in a combo with it. But TPU exists in many different colors and you can use it to create your parts, which are going to be almost like 100% crash resistant. At the time of recording this, the price for the A1 is 450 euros, something around 480 USD. But there is a promotion that Bambulab has, I think it's for the 2 years anniversary or something like that, where this printer is at 350 euros, something around 380 USD. That price, together with all the qualities that this printer has and the good that you can use this to do on your FPV drones, it makes it a very nice acquisition that you can have. Hopefully you got enough tips from Riley to create things like this, where you can do your own GPS mount for, in this example, the Cinebot 30. And enough from me to understand what kind of printers are good for you to do this and enjoy the synergy between these two worlds, the FPV world and the 3D printing world. This is what I have for you today. Thank you for watching and see you soon.